Hello, everyone. Welcome to another DI or direct instruction video on balancing chemical equations. So, what is a chemical equation? So, it is nothing but a written representation of a chemical reaction. Now, you would be given something like this to balance, okay? And take note, all the things on the left side, we call that the reactant side. And all things on the right side would be called the product side. Now, of course, substances are represented by chemical formulas. And if you see a number before a formula, that means that's the coefficient or the number of molecules. And the smaller number beside an element would be the subscript. It tells us about the number of atoms. Okay? So, and at times, of course, you get to see the states of matter, like a G for gas, L for liquid. Before you are asked to balance a chemical equation, you are asked to identify the type of chemical reaction that you have. So, what we have here would be the first one, synthesis or combination or union. So, how would you know if you have synthesis or S? That would mean an element plus another element. Now, a decomposition happens if there is a breakdown of the compound into two or more elements or compounds, right? So that would be a D for decomposition. SR would be for single replacement. Some books would have it as single displacement. That's also okay. But for purposes of just being common in writing down the type of chemical reaction or type of chemical equations that we are balancing, just say SR to mean single replacement. And that happens if you have an element and a compound. DR for double replacement. That's a case when you have a compound plus another compound. Now, combustion would be a hydrocarbon. So that would be substances containing carbon and hydrogen reacting with oxygen. So think of burning, right? Think of the burning process. The products are fixed or constant. It's always carbon dioxide and water. Now, in your booklet, set A, you are given 10 equations, chemical equations to balance. So there are blanks here, right? But of course, I want you to show your work. That's why you try and get loose leaves so that you can just be able to balance it better. Now, here we have what we call as diatomic elements because most of the times when you get to see the equation to be balanced, we have there hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. They're not simply written as H, N, F, O, I, C, or B. It's always with a two because these are all diatomic elements. And if I ask you what are the seven diatomic elements, how would you know that? Right? So I have here a mnemonic. So have no fear of ice cold beer. Okay, so that would help you out to memorize the diatomic elements. Now, let's delve into the first problem here. Initially, you have here Fe plus H2SO4 to yield or to produce Fe2 bracket SO43 plus H2. Now, in grade 9 science, you're you're just interested in counting the atoms or writing the formulas correctly, but the naming of compounds, you'll do that when you reach grade 10. So here, for instance, iron here or Fe, the same number of atoms on the left side should be the same as the one on the right side. So how do we balance that? So you are now putting in numbers before the formula. So you are now manipulating the coefficients. Never put a number here for, let's say, Fe2. No. So you do not change the subscripts. Okay. So these are fixed. What you can do would be to adjust the number outside. So notice if I put here a 2, 2Fe. If I have 2Fe on the left side, it should be that on the right side, I should also have 2Fe, which is correct. You have your 2Fe. So the iron or Fe atoms now are balanced, right? Same number. Next, hydrogen. On the left side, how many do you see? You have here a 2, but there's a 3 outside. Remember, the coefficient is shared by all. So the 3 is for H, the 3 for S, 3 for O or oxygen. So 3 times 2, that would be 6 hydrogen here. And on the right side, initially you have a 2. What do you do to make it 6? You added a 3 here. So that 3 times 2 equals 6. So hydrogen now is balanced. How about S? S by itself is, you see, an understood one here, right? But then you have a 3 outside. So that means you have 3S, 3S on the left. How about on the right side? So just like in math, brackets, right? So whatever is inside, if you have here a subscript, that subscript is shared to everyone here. So S here would be a 3, right? So 3. And so sulfur now is balanced, S is balanced. Now comes oxygen, the O. So 3 times 4 is now a 12. How about on the right side? So what do you notice here? 4, 3 times 4 is a 12. So if all the atoms are balanced, we can say that the entire equation is balanced, right? I know it gets confusing sometimes, like, I'm confused on this, Miss F. Okay, so let's see if we have this case. So if we have this, so let me just call on my pointer here, my laser pointer. So let's see. So this is, there's an understood one here, right? Now, what if I have here a 2? What, how is that? So here, how would you get the total number of atoms? So that would mean 2 is shared by everything, right? The 2 is shared with Fe, the 2 is shared with all these things in the bracket. So here, 2 times 2 is a 4Fe. Now this is now the S. But you see the 3 here, so 3S. But there's a 2 here, so 2 times 3 is a 6, right? And how about oxygen here? So you have 3 times 4, that would be 12. 12 times 2 is 24. So that's how it plays out. Okay. Now, the second problem there would be ethane, which is a hydrocarbon. And you are asked, what kind of chemical reaction is this? So is it S, synthesis? Is it D, decomposition? C, combustion? SR, single replacement? DR, double replacement? Of course, with combustion, we said earlier that it's always a reaction with O2 to yield the fixed products of water, H2O, and CO2, carbon dioxide. So this is actually ethane. So allow me to introduce you to the concept of hydrocarbons. And one family that would belong under the hydrocarbons would be the alkanes. The alkanes would have this formula, CnH2n plus 2. So it depends on the number of carbons that's present. So from there, you can easily predict the formula. So let's say if n is equal to 1, so that would be C1, but there's an understood one there. You don't have to say C1. So this is C. So 2 times 1 is 2 plus 2 is a 4. So that's why first member of the alkane family would be a CH4 or a methane. Ethane is this in our example, right? And if n is equal to 2, that would be, so this is now a 2. So 2 times 2 is a 4. 4 plus 2 is 6. That's why we have C2H6 for ethane, and so on, right? So let's try and balance the ethane. And we said that with this one, what kind of chemical reaction? So it's a reaction with oxygen to give you H2O and CO2. So this is combustion, right? So here, how did we balance this? So by inspection, originally you only have C2 here, right? C2. On the other side, you have a 1, right? So what would be a good number to place outside of the formulas? So we decided to put a 2 here, right? So let's say we have here a 2. So the carbon atoms now would be what? 2 times 2 would be a 4, right? And then on the right side, initially it was 1. What do I do to make it 4? You place here, you wrote down a 4. So that 4 atoms of carbon on the right side. So this would be balanced in terms of the carbon atoms, right? Next would be hydrogen, right? Hydrogen is what? 6 initially, but you have a 2 there. So 2 times 6 would be a 12, right? On the left. So it must be that on the right side, you should also be getting 12, right? So here, 6 times 2 is a 12. So H now is balanced. Now, oxygen. Now, a simple tip. If you have more of the atoms on other side, you start with that. So I'm going to just look on the right side here. So here, 6. So again, the coefficient is good for everything before it. So 6 is for hydrogen, 6 would be for oxygen. So how many oxygen for H2O here under H2O? So you have 6O. So you have 6O. And notice how I would write down the oxygen so that I do not confuse it with the number 0. So you kind of put some sort of a tail there, right? So 6 oxygen here plus, how about oxygen for CO2? So you have a 2 there, but there's a 4 outside. So 4 times 2 is 8. So 6 plus 8 is 14 oxygen. So initially here on the left, you only have 2. How do you make it 14? You place a number outside. So 7 times 2 is 14. So if all the atoms are balanced, you can consider the entire equation now as balanced. Okay? Now, moving on to the next one. You have KOH plus H3PO4 to give you K3PO4 plus H2O. Again, as I've said earlier, you don't have to concern yourself with the naming of the compounds, right? So, but this is, of course, potassium hydroxide plus hydrogen phosphate to give you potassium phosphate and water. Okay, so let's start with K, right? How many K do we have initially? It's just one, right? But I saw here a 3. That's why, let's start with a 3 here. 3K on the right. What do I do on the left side to make it a 3? We place here a 3. So that 3K on the left equals 3K on the right. Now the 3, the coefficient here outside, is to be shared with everything before it. So oxygen or hydrogen here, for instance, right? You would have 3H, right? Plus 3H here, that would be 6H, right? So I need to have 6 hydrogen on the right side now. So that's why the 3 here, 3 times 2 would be a 6. So this part now is balanced for hydrogen. And then oxygen. So I have here 3O, so that's 3 oxygen, and 4, this one, 4 oxygen. So 3 plus 4 would be a 7. So on the right, it should also be 7, right? So 4, right? 4 plus 3, because the 3 is for H, it's for O, right? So 4 plus 3 equals 7. So oxygen now is balanced. And last but not the least, you have P here, right? Phosphorus, right? 1P on the left and 1P on the right. So already balanced there. There you go. That's for this equation. Now al- another group, another hydrocarbon group that we discussed in class was the alkene group or the alkenes. Now they would have this formula, CnH2n, the general formula for alkenes. That's why um, in worded problems, sometimes I would say if n or the number of atoms is 2 and it follows this formula, what would be the resulting uh, formula, chemical formula? So notice if we use this now, like if n is equal to 2, so that would be C2. So this is 2, 2 times 2 is a 4, C2H4. So that's the first member of the alkene family or ethene. And then you have propene if n is equal to 3, butene if you have n equal to 4, pentene if you have n equals to 5. So you kind of remember a math now or the polygons, right? Penta meaning 5, right? So I can predict the number 6 now would be hexene, heptene, octene, nonene, right? Decene, right? So this is alkene. Do not confuse it with the alkane, A-N-E, because the two would also differ in the formula. So here, propene, that would be if n is equal to 3. If this is 3, C3H, what happens? So 2 times 3 is 6. So you have it C3H6. Or if n is equal to 4, what happens? C4. So 2 times 4 is an 8, C4H8, and so on. So there's a certain level of predictability when it comes to um, knowing the alkanes. And of course, let's take up the combustion now of ethene, right? So N equals to 2. Or I could just simply say combustion of ethene balance it. So ethene, and you might be confused, oh, how do I do that? Remember the formula CnH2n. So Cn, so N is 2, H2n, 2 times 2 is 4. So this is now the formula for ethene. And this combustion always with O2 to give the fixed products of H2O and CO2. So balancing this, you have a 2 there. So why not start with that? Make it 2C on the left. On the right side, how do I make it a 2 also? So you need to place here a 2 so that you have 2 carbons on the right side. So carbon now would be balanced. Move on to the next. H. How many hydrogen do you see here? 4. So 4H on the left. How about on the right side? So you have a 2 outside here, right? So 2 times 2, that makes it a 4. So that balances out the hydrogen here, right? And of course, oxygen here, 3 times 2 would be a 6. How about on the right side? So you have 2 oxygen, because remember again, coefficient is shared with everything before it, right? So that would mean 2O plus, so 2 times, so it's a 4, so that would be a 6. So 6, okay? So everything now is balanced. And if I take on the next one, I would say, let's say propane undergoes combustion. So this is now the type of chemical reaction that we are considering for balancing this equation. So C3H8. Again, remember the formula in your hand, CnH2n, right? So three, um, propane, this is now different, propane with the A and E, right? So CnH2n plus 2. That's why you have C3H8, right? So always reacting with O2 to give you H2O and CO2. Now, let's say I did not yet place the 543 here. So how would I start with the balancing again? So you have here a 3. Why not write it down? So 3C on the left. When you switch your attention to the right side, hmm, how do I make it the 3? You place a 3 outside. So 3C on the left, 3C on the right side. So carbon, balance. Now, next, hydrogen. Okay, it would be 8 hydrogen. Okay, put here the 8. How about on the right side? Initially, you did not have the 4 here, right? So how would I make it 8? So think of a number. When multiplied by 2 will give me an 8. Obviously, that would be a 4. So 4 times 2 equals 8. So 8H on the left, 8H on the right side. So hydrogen, balance. Okay? Now, oxygen. Now, initially by itself, it's just O2. But on the right side, you're done with the coefficients here, 4 and 3. So better start on this side now. So 4O, okay, 4O. And how about oxygen here? 3 times 2 is 6. That would be 10 oxygen. 10 oxygen. So what would I do with the 2 here? What number to be multiplied to give me a 10? Obviously, that would be a 5, right? So 5 times is 10. So all the atoms now are balanced. Now, another example here, right? So C4H10 plus O2, again, combustion, right? Combustion of what? What do you think is this? Alkane or alkene? Remember the formula, CnH2n plus 2. So this must be what? I'm waiting. So Cn, so C4H2n. So 4 times 2, 8 plus 2 is a 10. So this is now what? An alkane. Yeah, you're correct there. So if it's C4, remember you have methane, ethane, propane, butane. So this is butane. So again, how would you start to balance this, right? So here, do you think this is correct, people? 8C. So maybe this was not catch by my when I placed the number here. But if I want here to be 8, what should be before this one? Let me see if I have it correctly written. So it should be that you need to have what? Let me just add in. Let me just add in a number here. Insert a text box here. And this happens when you least expect it, right? So so let me just bold that out so that you can see it, right? And you can just, so technology is great, right? So this now, at the moment, editing, right? So there you go. So let me just save that and then let's get back on a bigger space here, okay? So here, So we said earlier this is butane, right? CnH2n plus 2. So how would we balance this? So if I place here a 2, the 2 is good for carbon here, 2 is good for hydrogen. Okay, so how many carbons do we have on the left? So 2 times 4, that would be 8 on the left. How about on the right side? How do I make it 8? Initially, CO2 is just CO2 by itself. So if I want it to be 8, I need to write down 8, right? So there you go. C now is balanced. Next would be hydrogen, right? So there's a 2 here. So as the coefficient, so 2 times 10 would be what? Correct. That's 20H on the left. How about on the right side? How do I make it 20? By itself earlier, this is just a 2, right? So to make it 20, you need to place a 10 here so that 10 times 2 becomes a 20. So that's how you balance the individual atoms or elements here. And finally, for oxygen, as a rule of thumb, you start on that side where the coefficients are already done. So in this case, it would be the right side. So let's count the oxygens on the right. So 10 here, right? 10 oxygen. And for this, you have an 8. 8 times 2, that would be a 16. 10 plus 16 would be 26. And how do I make 26 atoms of oxygen on the left? Initially, it's a 2, so I needed to place here 13. 13 times 2 is 26, right? So that's how you balance the atoms, okay? You sometimes it's best really to use a pencil with a good eraser. As you can see, even from the loose leaf that I've used here, right? Before I ink it, right? I use pencil first. And there you go, people. So we've gone through essentially number one, and then number two with a side discussion on alkanes, and then number three, side discussion on alkenes. Now, try and challenge yourself, try and complete now the balancing for problems 4, 5, 6, 7, 8, 9, and 10. Okay, people, so there you go. So have fun with balancing chemical equations. Ciao for now.